In example 5, we have one more problem where we want to look at solving a rational equation. We want to apply the same approach, but an additional step here is that we first need to factor each denominator in order to identify that common denominator as well as any restricted values. X squared minus 25 will factor as x minus 5 times x plus 5. Our second expression, we can factor out an x in the denominator, leaving us with x times x minus 5. And then that expression on the right-hand side of the equal sign, if we factor out an x, we'll have x times x plus 5. This allows us to identify our restricted values. We know that x can't equal 0, -5, or +5, which we could find by taking each of those factors set equal to 0. From there, we can multiply both sides by our common denominator, which in this case would be x minus 5 times x plus 5 times x, meaning our updated expression, our updated equation, will be x times x, after those expressions in the denominator cancel out, minus x plus 3 times x plus 5 will be equal to -7 times x minus 5. Multiplying through by the common denominator eliminated all expressions in our denominator, so we no longer have rational expressions to deal with, and we can multiply through to simplify and start combining like terms. So what we have is x squared minus x squared plus 8x plus 15 equal to -7x plus 35. We'll need to distribute the negative sign through that quadratic function, and then combining our like terms will leave us with -8x minus 15, still equal to -7x plus 35 on the other side. Then grouping like terms on the same side of the equation will give us minus x is equal to -50, or x is equal to -50. That value isn't one of our restricted values, so this is in fact a valid solution for that given equation.